unit. This unit is all about circles. So first thing we're going to do is talk about some vocabulary. So first of all, the definition of a circle are all points that are equidistant from some center. So I guess the two main properties of a circle is that it has a center point. So you got to define where the center is, and then you have to define the radius. The radius is the distance to all the points on the circle, right? The circle is really just the collection of all of those dots that are equidistant from some center, okay? So the radius is then the distance from the center to the circle. The diameter is the distance across the circle that goes through the center. The diameter is twice the radius, and again, the diameter is also a chord. So a chord in general is pictured down here. But we have all of these vocab words that we're going to discuss, and I kind of have pictures to go with them, right? So we have, that's an example of a radius, which we usually call little r. There's the diameter, which is a chord that goes through the center. The diameter is twice the length of the radius. The area of the circle, right, is the two-dimensional space inside of that object. Its formula, you've probably seen before, is pi r squared. The circumference of the circle is the distance around. That's really like the perimeter of anything, but in circles we call it the circumference, and the circumference is 2 pi r. That is an example of a chord, and so is the diameter. The diameter is just a special chord that goes to the center. A chord is just a line segment that connects 2 points on a circle. A tangent line is a line that just intersects the circle at one point, where a secant line would intersect the circle at 2 points, right? It would actually go through the circle. We have angles. We have a central angle here, so the angle that two radii form coming from the center is the central angle, and we'll actually figure out that the central angle and the measure of this arc length is the same. So this property we'll discuss at some point. We'll also discuss in this part right here, this is one we do today, that the radius and the tangent are always perpendicular, which means they form a right angle, which means we can do some Pythagorean theorem stuff. We also know this property that if we take two tangent lines, they for sure are going to be congruent. So take any point in space, draw the two tangent lines of the circle, and the two distances from the point to the point of tangency are equidistant, which means they're congruent. We know that going around the whole circle, we have 360 degrees. We have an arc addition postulate, which says that we take that arc plus that arc plus that arc, we get all the way around, which means the three arcs together make 360, or however many arcs there are. Other random properties. This is really kind of the next video, but if you have two congruent chords, they have to have congruent arcs, and also that's a biconditional, which means that if you have congruent arcs, you know that the chords must be the same length, meaning congruent. Remember, you have congruent chords if and only if you have congruent arcs. This one's a little tricky, and actually in a future video, I say this wrong. So this is me in a previous video actually correcting it. I say this is a biconditional. They're really similar, but they're not actually identical. So if you are a perpendicular bisector, see how this line right here is a perpendicular bisector? It cuts it in half and it's perpendicular. Then that thing must be the diameter. If you're a diameter, that doesn't mean you're the perpendicular bisector of every chord, even though in a future video I think I might accidentally say that real quick. However, this is true. If the diameter is perpendicular, well, then it actually must bisect the chord. Okay. Congruent chords are equidistant from the center, so if we have two congruent chords, we know that the distance they are to the center, the two red lines, are congruent, and that is actually a biconditional. So if you have two chords that are equidistant from the center, you know the chords must be congruent. And then these are future things that we're going to spend a couple days on. We'll spend 1 or 2 days on the arc length formula on how to figure out the arc length relative to the angle and the radius, and then this sector area. So the area of this little pizza slice, we're going to figure out how that's related to the angle as well. Okay, this will get you started on circles. Again, the first day is really more about the vocabulary and all of these relationships, and then we'll build towards circumference and area and arc length and sector area. But this will get you started.